So today we're going to talk to you about twice differentiable functions. First, we're going to explain what it means for a function to be twice differentiable. That simply means you can take the derivative twice. So if you have a function f of x, then f of x has a slope at each and every point, and f prime of x has a slope at each and every point. And f of x and f prime of x are both continuous. So if you put a pencil on the graph, your pencil's not going to go off the graph. It's just going to keep on going until the graph ends. Now we're going to talk to you guys about relative minimums and maximums. Relative minimum is when the derivative of a function changes sign vectors from negative to positive. So the slope goes from negative to positive. And relative maximum is when the derivative of a function changes sign vectors from positive to negative. So the slope is going to go from positive to negative. And now we have a question from AP Calculus 8B 2014. It's a question 5. It was on the actual AP test. It tells you that it's a twice differentiable function. Both f and g, both are twice differentiable. And the part A asks about the relative minimum in the interval -2 to 3. And you're going to have to justify your answer. So here's how we're going to do it. So as you can see, what it means by relative minimum is the sign vectors are going to change from negative to positive, because that's when you're going to have a relative minimum. So as you can see, we go to f prime of x because that's the derivative of f. So as you can see here, from here, it goes from negative to positive. So you know x equals 1 is the answer. So here's how you'll write your answer on a test. X equals 1 because at that point the slope vectors of f prime of x goes from negative to positive. So that's how you can tell them that you know, like, your answer that's the answer, because that's how the slope vectors are changing. Now we're going to talk to you guys about the mean value theorem. The mean value theorem states that if f of x is defined and continuous on the interval a, b, and differentiable on the open interval a, b, then there is at least one number c such that f prime of c equals f of b minus f of a all over b minus a. So all you have to do is take the derivative of f of x, do f prime of c, and then you set that equal to the slope of the interval. And the same thing is applicable for the derivative of the function. So f double prime of c would equal f prime of b minus f prime of a all over b minus a. And we're going to go back to the question, because the question for part B asks, explain why there must be a value c for -1 to 1 such that f double prime of c equals 0. So right away, you know, like, we're going to use the mean value theorem for the derivative, which is f double prime of c equals f prime of b minus f prime of a all over b minus a. And here's how you're going to justify your answer. F prime is differentiable, f prime is continuous on the interval. That's how you can tell them that here it meets the criteria of mean value theorem. And you can go ahead and do the process as we did, f prime of 1 minus f prime of -1 all over 1 minus a -1. That gives you 0. So we're good with that. So therefore, by the mean value theorem, there's at least one value c in the interval -1 to 1 such that f double prime of c equals 0. And we're going to go back to the question again, because there are two more parts for this. And the question asks if there's a function h of x equals ln of f of x, and you have to find h prime of 3. And then part D asks about evaluating an integral. We're going to show you how to do that part. So since they ask h of x equals ln of f of x, and they want h prime of x, so first you're going to find h prime of x. So you do h prime of x equals the derivative of ln of f of x is just 1 over f of x, but remember, we're never done. So you multiply that by f prime of x. So, and now you evaluate that function for h prime of 3. So you plug in 3 wherever you see an x. So 1 over f of 3 times f prime of 3. And in the chart, it tells you what f of 3 equals. So if you go to f of x, f of 3, it equals 7. So 1 over 7, and then f prime of 3. So you go f prime of x. F prime of 3 is 1/2. So you multiply those two, and you get 1 over 14. And now we're going to go ahead and evaluate the integral. So the integral is from -2 to 3 of f prime of g of x times g prime of x dx. So first, There are a couple of ways to do it, but one we did it a different way. So let u equal g of x, and so if you take the derivative of both sides, you get du equals g prime of x dx. So now you can replace the u over here with g of x, and you can replace g prime of x dx, which is right here, with du. So you get, and you have to change your upper and the lower bounds, because if you don't, then you're still solving for x and not u. So you plug in -2 here, and you go to your chart, and you see g of -2 is -1, as you can see here, and you can for the upper bound you plug in 3, and from the chart you can see g of 3 is 1. So your upper and the lower bounds are changed from -1 to 1. So you have -1 to 1 of f prime of u du. To solve that integral, what an integral does is it's the antiderivative of a function. So if antiderivative of f prime of u is just going to be f of u. So that's how you know, like, integral of that is just f of u du. You plug in your upper bound, you plug in your lower bound, subtract them, and from your chart you can find that f of 1 is 2 and f of -1 is 8. So you do 2 minus 8 equals -6. And that's how you do the whole problem.